Hello everyone, this is Cadillac1, and it's good to be back making tutorials for you guys. Today we're going to be talking about threads. Today we're going to be making a runnable thread that's going to do calculations, send it to a queue, and an actor is going to retrieve that data from the queue and print it out to the screen. So let's sit back and let's begin. Okay, so we're going to start by making a blank project, a C++ project, and we're going to name it Thread Fun. And let it create. We'll be back when it's all created. Okay, the project is now created. Let's now start by creating a new C++ class. We'll make it an actor for now because we're going to change it to be a thread object. We'll call it thread calculator. We'll put it in public and create the class. And we will create another class. This will actually be an actor class that's going to ingest all the data and print it out to you. So we'll call it thread actor. Put in public, create the class. Okay, so now we created our thread actor and our thread object. So we're going to go to the thread calculator first, and we're going to start our bits to readjust to make it a thread-based object. So first off, we need to get rid of all the actor things that are in here. I'll go to the .h. We don't need the generated.h. We don't need the grain framework actor or the uClass or the API, and we're going to add our dependencies. So we're going to have include core, public, hal, and runnable.h. Oops. Runnable, there we go. Cool, so now we're going to also add our forward declarations. Forward declaration. We're going to have our class FRunnableThread. In our class what was it called? Thread actor. There we go. So the reason we do this is because we need to forward declarate FRunnableThread, because basically runnableThread is just a task where it'll just run through a particular calculation or whatever you want to do on a thread. It'll initialize, run, and then stop. That's essentially what the whole thing is here. And of course, we need a reference to thread actor to feed the queue to. I mean, you don't have to use a thread actor in particular. You could just do it through the thread and get the queue there. But I'm doing it in a more of a different kind of real world scenario to where we want a thread to particularly do a task for a specific actor and retrieve and get the results. So we're going to change the actor portion here to FRunnable. Get rid of the generated body because we're not using that for actor. We're not using begin, play, or tick. And same thing we're going to do in the CPP file. We don't need any of this at all either. But we will need the constructor, but we'll readjust it accordingly. So let's, of course, our thread calculator is going to have a constructor. So we want to feed it how many calculations we want to give it. So we'll do a int 32. For calculations. And of course, we want to feed the actor we're referencing from to feed the data into the queue. So it'll be a thread actor. Let's call it fun actor. Why not? Our constructor is complete. Now, so here is the 3 methods you're going to need to know for doing runnable threads. So there is the virtual bool init. This will initialize the thread if you need to do particular things to initialize. Say, for example, let's say, hey, I need to apply particular Boolean to say, hey, we're going to start the thread and then stop the thread, however you want to do that, or anything above that bit. The next one is virtual uint 32 or unsigned 32 and run. Let's fix that. So run, of course, runs the thread, runs the calculation, or runs whatever process you want to do on the thread. And you could also, you don't have to do like a while loop, but you have to do a while loop if you want to consistently run through a loop of processes throughout a thread, or you just have to do one process for whatever you want to do as well. Next bit is virtual void stop. Of course, this is the method that stops the thread. And if you have any particular things you want to do during that stop, you could do it there. And that's about it. That's all you need to know about the thread side of things. So let's go ahead and go to the thread actor. And let's add a few particular values here. So we want to have our dependencies. We're going to be calling our thread to create it, initialize it, and create a pointer for it, etc. So we're going to include thread calculator.h, include, include hal/runnable.h, and also include hal/runnableThread.h. This will make sense once we get a little further because we need to create a FRunnable thread to hold the container for the current thread calculator thread. So let's go ahead and do one bit importance here. So we want to create a TQueue int32 because we're just going to do calculations in int32. So we're going to call this the thread calc queue. This will hold all the values for that current thread that's being shot into the queue. The reason why we use a queue is because it's thread safe. What I mean by thread safe is, say for example, we were just getting a 32 current calc, right? So if you shoved values directly into here from the thread, say, okay, in the thread, once we get where we can find it, say in the run thread, I'll show you here in a bit once we get to that point. Say we apply the calculation and say current calc equals the new calculation. If we do that, that's not thread safe because of the fact that the thread calculator thread, the runnable thread, is running on a different parallel loop timing compared to what Unreal is running on its game loop. And if we try to do that mid-calculation or when it's assigning it, it's going to crash or cause improper calculations, incorrect calculations, etc. So that's why we use a TQueue, because, we could get the first in, whatever's in there, and then be able to pop it out, and just get the whatever is currently in queue. And also we could do a check, hey, is it empty? Hey, is there a current value here? We're able to get a, how would you say, a more defined, safe way to grab the values from the thread when we're getting those values to check. All right, moving on. So let's do a couple more things here. We got to do let's do our current cycle here, right? So we want to have a method to print the calculation data, print calc data, we'll call it that. And then we'll have a int32 processed calculation. This will give us the current, there we go. This will give us the current process calculation from the queue to print, right? So then the next bit, we want to create the pointers for the runnable tasks. So we're going to say class thread calculator. And we're going to make a pointer called calc thread equals null pointer. So this will make sure it's null from the get-go, and it'll keep it that way. And then we're going to go to the FRunnable thread current running thread equals null pointer. So try to give it a little understanding here. So this runnable thread object will contain, it's basically holding the container for what is the current runnable, right? So what that means is that it needs to have a particular container to say, hey, I'm creating a thread based on this particular runnable. So then it knows, so then we have a better pointer bit to kill the thread, be able to delete the thread at the end of our life cycle. So let's see, make sure we got thread calculator spelled correctly here. I'm not sure why I think it's because IntelliSense being weird, but that's totally fine. And of course, we're going to have an end play as well, because once we're running a thread, if we're killing the app while we're running the thread, we got to make sure we're safely killing that thread. Because if we don't, it will lock up the app and it will most definitely cause a definite freeze or a crash. So we're going to say virtual void end play. Of course, the typical, if I could get my parenthesis here, there we go. The end play, reason, type, if I could find it. The end play reason, there we are. And end play reason. And override, because it is a virtual method, we are overriding. Cool, so I think the next bit is, of course, let's apply this logic here. Let's see, make sure we got our constructor set. Yes, we do. Cool. So let's go on to here. Let's implement these methods. Create implementation. And process calculation implement. And then let's implement our end play. And there we go. All of our methods are here. And now let's do our cool things here. So let's go ahead and go to print calculations. Let's do that here quick, right? So this is where I'm trying to say, when we're trying to print the calculation, where you want the calculated thread queue to check if it's empty or if it's been dequeued. So let's take a look here what this looks like. If not, let's see what our name is, thread calc queue dot is empty and thread calc queue dot dequeue, and we need to have a processed calculation. So what this if statement is doing here, so this checks if the queue is empty and dequeue. So what that does, it grabs it from the first part of the queue. Dequeue grabs the first part of the queue and puts it into this reference. Oops, we don't want the process calculation as a method. That's a variable. So it shoves it into here. So it says, hey, we're going to put this value that's in here and put it into process calculation. Okay, let me see here. I'm spelling things wrong. There we go. And that's not a method. Processed. There we go. So this will shove this into here. We don't need this method as well because that doesn't make sense. So, and if it doesn't have anything in here, this also is a check, or if we dequeue and there's nothing in the queue, it will not put anything in here and it returns true or false. This is a Boolean method. So if we go to the definition, this is a bool, dequeue. So if we have no value in there in the queue, it will give us a false statement. If there is, it'll give us a true statement. Typical standard stuff here. So then in here, so if we do have the value in here, we're just going to do our typical UE log, log temp, warning, text. We'll say processed calculation, and then, and %d to give us a decimal, and then comma, processed calculation. And that's it there. So now let's go create another method here. So we want to create a method that will initialize this process. We're going to do this in Blueprint as well. I'll show you here quickly as well. So this will be a U function, blueprint callable, category equals, let's call it calculations. And then we'll call this void init calculations. We'll give it an int32 underscore calculations. There we go. And we'll make this implemented. So then in this method, this is where we do a lot of our initializing of the threads. So this is going to be really crucial. And also we got to do an if statement here. If, make sure calculations is greater than 0. Otherwise we will want to calculate calculations that aren't 0. So we're going to do calc thread So calc thread, of course, is the thread calculator we are using for the calculation of the thread. So it equals new f thread calculator. And then we want to, hang on. It's not giving me the constructor. Maybe it's just because of rebuild. But anyways, there's two parameters in here. Of course, you see it here. There is calculation, the int32, and the actor we're referencing. So we're going to use the calculation. We use calculations, and then this, because this is the object we're referencing, which is our this pointer. And after that, we need to give it the container. Current running thread equals FRunnableThread create. This will create the thread. So it needs to know what thread are we running. We're running the calc thread, and we'll give it a name. It needs to give a thread name. So we'll say text calculation thread. If I could type today, there. And that's it. That's all you do to run a thread. But we want to make sure, else if we don't have a calculation greater than 0, let's say ue log temp warning text calculations must be greater than 0. There we go. And that's it there. So now that we have all this set, let's go back to the thread object, right? So we're going to need a few things here. We're going to need a Boolean to stop the thread if you wanted to kill the app, right? So if you don't do this, if you don't have a bstop thread or any way to kill the thread and we end the app, it's just going to crash the engine. It'll definitely do that. So we're going to say bool, we have a simple Boolean b stop thread. And then we need that as well. So then the calculation bits, right? So we're going to need, let's make these all private. Put this back here. And we're going to say int32 calculations. This will give us the amount of calculations from the constructor. So basically when we give the implementation here, because that's what we need to implement those here quickly. But let's do that here now, actually. Implement our methods so we don't have to worry about them later. Hit run and stop. Get these all set and going. Awesome. All right, so then let's do another bit. We need to actually count how many iterations of the calculations we're doing. int32 calc count. This will tell us, every incrementation of the loop we're doing, we want to increment our loop of how many calculations we've done because we're feeding it how many calculations we want to do. So next bit, we need the reference to the thread actor. So we say a thread actor, and we'll call it current thread actor. And then the last bit is the current calculation that has been calculated. Current calculation. There we go. So this will feed, when we get done with the whole loop, we want to feed that. So let's go ahead and start with our constructor. And of course, in our constructor, we want to make sure that things are in the correct conditions. So we say if calculation is greater than 0 and fun actor, if that exists, let's assign them. Calculations equals underscore calculation, then current thread actor equals fun actor. Awesome. And that's it. Well, give her that insert and semicolon. Cool. There we go. All right, when we initialize, we want to do a couple things, of course. We want to say bStopThread equals false because we are not stopping the thread. We are beginning the thread because we have initialized it. And we want to make sure that calc count equals 0. And then we want to return true, saying to the initialize, hey, we're done doing our initialization bits. Let's start the run of the thread. So in our run thread, we're going to say while not bStopThread. So while we're not stopping the thread, let's do these calculations bits. Also, we need to do a check within here. We got to say if calc count is less than calculations. If that is the case, then we'll start our calculations. So this is kind of a weird calculation bit. So we're just going to do int32, new calc. Actually, we could just say current calculation equals current calculation. Actually, just say plus equals fmath rand range. Let's do 20 to 400. That sounds like fun. 20 to 400. And then we'll do current calculation times equals fmath rand range. We'll do, how about 2 to 500? That sounds fair. Cool, so we have a calculation here. And then we'll do also current calculation minus equals fmath rand range 10 to 500. Just going to go wild on these calculations. Just go really fun with it. So then we're going to say current thread actor thread calq.enqueue. And we're going to put current calculation. So the reason why we're doing this here, we're going to do a bunch of calculations. And then here, once we're done with the calculation, we want to add it to the TQueue that's attached to the current thread actor, which is thread actor, which is this queue here. Then after that, we want to increment our count, calc count plus plus. I can do that. Then, of course, if we're done, else if it's done, we are going to stop the thread. B stop thread equals true. And that will completely stop the runnable thread. And at the end of it, we want to say return 0. So that would be at the end of the bit. It's just going to say we're returning a value, which is 0. We're saying, hey, we're done with the thread. And that is it for this part of the thread bits. So now we could go back to our thread actor, and we're going to take a look here. We're going to create the thread. If not, create it in 0. And we're going to say make sure it's empty. And when we dequeue, is there a value? Let's print out that bit. And of course, during tick, we want to print them out. Print calc data. So that on every tick, we're going to keep printing the data. And if there's, of course, there's no data, we're not going to print anything. So here's where it gets kind of interesting here. On end play, we're going to say, of course, we're going to say super end play reason. So we get make sure you have the rest of the end play process keep continuing. This is where it's really, really important. We got to make sure if we have a current running thread and calc thread is valid. We don't want to do this if there's no null data, or otherwise it's going to crash the engine. So we want to say, so during this process, it's kind of like a quote unquote mutex, which is kind of in a way, if you want to change a value on a thread, you can't just say calc thread dot b stop thread equals true. You can't do that because you have to make sure you suspend the thread in order to be like, hey, stop everything real quick. Besides the game loop, it says stop this thread real quick, suspend it, change this value real quick, and then let's continue and kill the thread. So in this process, we would do something like this. We say current running thread, which is the container, the holding container for the calc thread. We say suspend, true. We want to suspend it. So what suspend does, let's go back here. Let's do dot suspend. So this is what I say should pause. Yes, we want to pause this thread real quick because we want to change the value here. And then we're changing the value of stop thread to be true. Then we can do the same thing here. Go to current running thread, suspend. Then we say, are we suspending it? No, we're continuing back on. Then we're going to current running thread. We're going to kill the thread. And do we want to wait? No, we're going to false. There are situations where you want to wait for a particular process within other, so you have subthreads. That would make sense. But in this also case, we want to do that. Maybe the current running thread, wait for completion. this will wait for the completion of the thread because we just changed the value of stop thread to be true, and we don't know when that last iteration is going to happen. So we want to make sure we wait for the completion of that, and then it will kill it. Once it's all completed, we want to delete the pointer, delete calc thread. The reason being we do this is because it's not necessarily an actor, like an actor or like a U object per se, because they have particular, well, yeah, U actor kind of doesn't either. Well, not U object, not U actor. U object doesn't have the particular thing where it automatically has an end play or anything like that. Like end play does a bunch of handy things for you when you end the process of the application. You have, I mean, in C++, you have to make sure, like especially in native bits, you have to make sure you know when you're creating something up here, for example, you're creating a new. When there's a new, you're very gosh darn sure you're deleting it when you're done with it. That's just the nature of C++. But hey, you know, better in charge than not know what's happening behind the scenes. And so far, that is it. That's really all there is to it. Let's build this. I might see some errors, but we'll see. We'll see how I did this on the fly. We'll see how this goes. And of course, we got some errors. Let's take a look here. What's going on? Okay, undefined. Oh, forgot to put the definition here. Because we're doing for declarations, we got to make sure we include thread actor.h. We got spell include, right? C. Now it should probably work. Nope. Still got some issues. Oh, that's where we had the problem. F thread. Because we didn't change things in the beginning. But that's fine. We could fix this up. This will work fine. So we do that, and that should fix that up. Let's go ahead and build this now. Nope, still problems. So now we're on a thread calculator. So we need to change this all to F. I thought it was just that, but that's okay. We make mistakes. That's how we learn from this, right? See, and there we go. Build process. Let's go ahead and start the engine. All right, the engine has now started. Let's go ahead and create a new blueprint class based on our thread actor. All right, select. Well, let's call it thread actor BP. And let's open her up. And let's go ahead and add a method here. Simple, very straightforward. Just add a delay, wait about 2 seconds, and then let's begin our log. And we'll say init calculations. And we'll give it, what, let's say 50 calculations. Compile, save that, exit out, put this in the scene, and make sure our output log is present, and let's see what happens. 50 calculations done. And then let's go ahead and do 500 calculations. Let's just do, let's do 500. I'm going to try to kill it in the process and see what happens. If it doesn't crash while we're doing this, and it shouldn't crash. So, oops. All right, sorry about that. Let's open this back up. It seemed to be fine. Let's try that again. Hit play, and let's try to kill it while it's doing these processes. No crash. Cool. So let's actually see how the process goes through here. So I'm running through here. There's no lag, nothing happening during the calculations. I mean, God forbid, these are, you know, kind of simple calculations, but say, for example, you're finding prime numbers, or example, that's also a heavy calculation. And that concludes the tutorial here. Feel free to subscribe. Feel free to come back for more tutorials here in the near future. And I'll see you guys again next time.